So today I'm presenting the mobile robot system by me, Daniel Jauchd. I'm a solo group. So, our goal is to design a robot that utilizes the Arduino. That Arduino powers the servo, which a servo powers the ultrasonic sensor which sits atop of it, and the whole robot is moved by these motors. There's a bunch of other parts, but I'll get there later. The Arduino individually talks to the ultrasonic sensor, which sends it from the transceiver and then receives it later down the line. This is measured as distance. This is a rough graph of the map that we use. This is what it would look like in real life, though. We're going to have to find each box individually. 1, 2, and 3. There'll be one more, but that's off to the right. That's my robot. It's able to move its head, left and right, 180 degrees to be exact. After checking where it is, we're going to get a data measurement from each degree from the ultrasonic sensor. We'll just use this for scale. And there's our robot and there's our map. Every 5 degrees, we'll have an averaged result. And over the 36 times that goes across, we'll get a different number for the distance averaged. So we'll see the boxes come out. Then we can tell it to move forward towards it. Now gee, I wonder how that graph looks, because that time to scan really took a while, as this is really probably the longest robot that it will scan of the entire class. It takes about a total of 10 to 15 seconds to scan its full distance. But since it's averaged and calculating every degree, you'll get probably the most accurate result possible. See, look at that. You can see each box individually from a 3 graph. The one on the left here, we have to give it an angle and a distance. I set that at 90 and 0.6. But you saw how that left motor moved a little bit too much, so it'll check it again, in case you're a little bit off. Then, you just give it another angle, 90 degrees, and it'll go straight forward. And there you go, it hit it. For the next video, I'll explain even better. There's 2 different obstacles, so it needs to A, adjust itself, and then B, get the right distance. So it overshot it a little, but that doesn't matter, as it's going to scan again, and we can correct it by going, like, I'd say 10 degrees more to the left. And that's exactly what I do in all of my tests. It'll scan again, I'll give it an 80 degrees, so it'll go 10 to the left, and it'll hit. Now, the solution was supported by what I learned into the Intro to Mechatronics class. Just looking at the code itself, everything here has been taken from the entire class. I've copied this code from other codes before. Very specifically, the function used for plotting data and getting all of that data into an array, I've used countless times already. And the flowcharts, this class specifically taught me how to get those results and how to get to the correct if statements and use statements. Now, you might be thinking, well, I want to see this robot in action. I want to see it do a full thing. And I've just got that for you. So, some of this is sped up, but the, I'll explain as best I can. The very first one, you can easily see we're going to go from left to right here. So, we want to go to that arrow, which is around 20 degrees. And then I'll write down 20 degrees. But then I'll also write a distance. I write 0.6. But you want to get as close as you can to that dot where it lines up, because then it'll know to stop before it gets there. Now you see it'll rescan. This is what I mentioned before. This is the reanalyzing. In case you missed, this is what's going to fix it. I'll show you missing in the next one. You can easily see that it's right there, 90 away. You go straight forward, we hit it. We get a nice little message in the bottom, and then it'll rescan. As I mentioned, this is probably the longest scan that it'll ever take, but as you can see, it gives good results. Now we know I want to go to 110, but I messed up and I accidentally put 140, so it shot to the other one. 0.6, it undershot, and you'll see now that when I try and fix it, because I want to go in order left to right, I want to go over there. It just doesn't have enough oomph to get it to turn right, and it missed. But it tells you, hey, it could not be found, just try again. It'll return, it'll do another scan, and you're going to be able to retry again. There's that good graph. Straight in front of us, we want to go to about 80 degrees, and that's what I write. I write 80 degrees, 0.6, and that gets really close. But even if it touches, it doesn't matter. It needs to scan first. And so since we're close, I could just write 90. And I do. I just write 90, it hits it, and it turns around. And there we go, 2 down, 2 to go. It'll scan one more time. We've got next is the thin one. And we notice it very easily with the code. We turn down to 105, 110, and I write 0.7. We hit it this time, but as I said, it won't know until we scan it completely. And it's right there. We can tell that from the code. You could probably do this blindfolded. And then finally, we got our last one. So we'll see how that lands. Now here's an interesting one. In this graph, we see that there's not much distinguishing it. Like, what if it's the left one? What if it's the right one? We're not sure. I'll guess the far right one, just because I can see it. But automation, like, what if it messes up? Well, that's where we've got the second scan. It will do it again, and we can easily see that there's that hump. We found the box finally. So we'll turn to it, and we hit it. And there you go. That's the finished box hit. And that's a full completed run. With that completed run, you know how many issues that there can be during the run. But it's easy to fix, and I think I did a great job at introducing that to make sure it's easy for the operator. That made multiple people try it, only had about 3 to 4 minute times. And with the accuracy about 5 to 10 degrees, it was pretty good. And the success rate of people hitting boxes was about 87% at the end.